Aerial imaging speed with FullChip from Panoramic Technology. This is an alpha version of the software. This is the setup for this demonstration. Basically, there are two compute machines. These machines have two Xeon processors each, and there's two machines, so that's 4 processors total. Each one of those has 10 cores, so that's 40 physical cores at 2.4 gigahertz. We're running the viewer over here. This is the viewer and the controller, and the layout server database is actually running on one of these machines. So in this example, we're going to simulate this full layout. So here's the layout, and we'll go to the controller. We're simulating layer 10, which was the OPC layer, and we'll just hit the simulate button. And it clears out the database here. It clears out the layer. If you're familiar with our other software, Hyperlith or EM Suite, you will recognize the SimRunner. It uses the SimRunner infrastructure of our other software. So this job is sent to SimRunner. On SimRunner, you can see we have 40 PSSs. That's 40 workers that are doing the tiles. And you can see the workers sending their results back in real time. It's, kind of a novelty. It's not something you would do on a production basis, but to watch it, the results come back is kind of fun. And you can be overviewing it or reviewing it while they're coming back, so that's kind of nice. Actually, multiple users could be doing it at the same time. So we'll wait for this to finish, and then we'll time it. It's almost done. Anyways, I've already run this, so I'll cut back to the slides here. And here's a summary. It was 40 cores. There were 480 tiles. Each tile was 10 by 10 microns, but only 8 by 8 microns was usable because there was a 1 micron guard band. This took 102 seconds, and that works out to 7.5 microns per second. 7.5 microns squared per second per core. So assuming a big chip was 10 millimeters by 10 millimeters, that works out on 500 cores. Let's say you had 125 quad-core machines. That would be 7.38 hours on 125 quad-core machines for a 10 millimeter by 10 millimeter chip. Now, there's many factors involved here that we didn't discuss. This was only aerial image calculation without any resist. The layout was OPC'd, but the density of the layout plays a factor because the spectrum computation time can be dependent on the density. And there are a few other factors, but I think this demonstrates that the speed is in the ballpark of what it needs to be.